this question from the 2020 paper, we'll be covering concepts related to minimum cut, maximum capacity. So question 4 says the training program 1, which is referring to the training program in the previous question, which is the team must run to exercise station O. Okay. Has the cricket team starting from S. So let's say S, and running to exercise station O. For safety reasons, the coach has placed a restriction on the maximum number of people who can use the tracks in the fitness park. The directed graph, because there are arrows in it going in a particular direction, shows the capacity of tracks in the number of people per minute. How many different routes from S to O are possible? So all you have to do is very carefully and systematically go through. So that is 1, that is 2, that is 3, and that is 4, and then you come down here and so you can then do that, and do that. Then you can do this one, that one, and finally you can do that one. And if you finally count them all, you will get 10. When considering the possible flow of people through a network, many different cuts can be made. Determine the capacity of cut 1. Let's determine the capacity of cut 1. So we look at all the edges with the forward flow that intersect with cut 1. And this edge is 20, this edge is 12, and this edge is 20. And when you add them all up, it gives you 52. Let's look at the next question. What is the maximum flow from S to O in the number of people per minute? Now this can be done in many ways. The one that I usually find easy is to go along the paths and see what the minimum capacity is, because that will be the bottleneck. If you have, for example, a road that can accommodate 20 and another one that can accommodate 22, it doesn't matter that we can accommodate 22 over here, only 20 will pass through, because 20 will reach here and then only 20 can go through to the end here. So using that concept, let's follow the different paths and see the capacity that will reach the finish point O. So if I was to go along SMO, I can see that 20 is the smallest number, so you write it. So the full capacity goes through here and only 20 of 22 goes through, leaving with the capacity of 2 that can still be accommodated. But because the full capacity moved through this particular path, it's not possible to move any more people along that path, and so you can cross that out as a track that you can't go through again. So going back to other paths, let's systematically go downwards. I'm going through to look at S, T, U, N, and O, and I can see the smallest number along this path is 10. So that's capacity of 10 here, so I'll write that here first, and only 10 goes through the 12 and 10 goes through the 12. So here we can see that maximum capacity has moved through here and here, and we can't go through those paths again to accommodate more. So let's now look at another path. The only one that's left is to go from S to R and then Q and then anywhere else we can go. But we can't, we can go from S to R to Q and U, but it's no use going to N because that track is reached maximum capacity. So let's go from U to V to O. And the smallest number along that I can see is 5. And so I write 5 here. And that's reached maximum capacity, and only 5 go through there, 5 go through there, and 5 goes through here and here. So clearly this one has reached maximum capacity. But from what you can see, there's plenty that can still go through SRQ. And so let's choose another path that does not involve the one that's reached maximum capacity. So let's go through SRQ, V, and there's still 7 that can go through in this particular track. So let's go have another 7 go through because we've still got a balance of 20 over here. And so 7 goes through here, then that makes it 12 out of 20 there, and 7 goes through here. Let's write 7 there and 7 here. Now clearly we can see that here in this particular edge, 12 out of a capacity of 12 has been reached. Okay, so 7 plus 5 is 12 out of 12. So we can't go through that edge anymore. So the only edge that is left is SRQ, V, P, O, and SRQ, P, O. So I would recommend that the smallest value that lies along that path is 5. And so if I was to take, because here the capacity that's been reached is 7 out of 15, so we still have a capacity of 8 that can go through. And here as well it's 12 out of 20, so 8 more can go through. And here it's 12 out of 25. And so a lot more can go through that. So let's say a capacity of 5 goes through that, a capacity of 5 here. Let's write down 5, and 5 more here, 5 here, and 5 here. Now that implies that we've reached maximum capacity along this edge. Now let's look at what the remainders are. We can, adding these, that's 12 plus 5 is 17. We have a balance of 8 that can go through there. We can go through, this is addition is 17 out of 20. And so that means 3 can go through here. And we can see along QP 10 can go through, and along PO 5 can, there's still a capacity of 5 that can go through, of which the smallest value here is 3. So we'll say 3 out of 8, and so let's write 3 there. 3 out of 3, 3 out of 8, 3 out of 10, and another 3 here. So we have reached maximum capacity here. And clearly, if that particular path RQ has reached maximum capacity, we really can't go through any other path leading from there, even though there is a capacity for more people to be accommodated. And so when we reach this point, we stop and we add all the values, and it gives you 10, so it gives you a capacity of 50. The other way to do it is record all the paths. For example, SMO is the first path, and the smallest value along that path is 20. And so that's 20, reached maximum capacity. And then the next path is S2UNO, and the smallest value along that path is 10. So these have reached maximum capacity. And the next path through which anything can flow through is SRQUVO, and the smallest value there is 5. So that's reached maximum capacity. And the next path that we can accommodate people through is SRQVO and SRQVO, and the smallest value there is the smallest value that can be accommodated along this path is, we can see that I can accommodate 7 along here, is 7 and 7 here, and another 7 here, and another 7 here. And so that leaves me with one last path, which is SRQPO. And here we've got a capacity of 12, leaving me with a balance of 10, 12 leaving with a balance of 8. And along that path, the smallest value is 8. And so 8 out of 8, and 8 out of 10, 8 out of 10, and 8 out of 10. And that means that we can't go along any more paths. And that, when added together, gives me 50. Thank you.